All right, question number 11. We want to know, does this graph represent a function? In order to determine if the graph is a function, we need to check the vertical line test. So if I drew a vertical line anywhere on this graph, it should only cross one point. It looks like these two dots are vertically aligned. So if I was to draw a vertical line, it would hit this point and it would hit this point because they're both solid dots. That being the case means it would fail the vertical line test. A vertical line should only cross the graph once, and in this spot it would cross twice. So it fails, meaning it is not a function. This is not the graph of a function. So is the graph a function? No, it is not. All right, number 12, we want to talk about domain of a function. So when you look at domain, there are three scenarios you want to think about, okay? Or three types of equations that will cause you to have a restriction in your domain. Okay, so your domain is all real numbers I use the pound sign to denote numbers. All real numbers, which is also denoted by a boldface R, or you can do it in interval notation, negative infinity to positive infinity. So your domain is all real numbers unless one of these three situations is present. Number one, fraction. If you have f of x, specifically something with a variable in the bottom, your variable is normally x. So this is a function of x, we have an x in the bottom. If you have an x in the bottom, you have to be mindful that you cannot divide by 0. So you have to take the denominator and set it not equal to 0. Once you solve for x, whatever you get, x cannot be 0 in this case. That would be your domain restriction. So your domain would be x cannot be equal to 0. In interval notation, if you think about this as a number line, you have negative infinity here, positive infinity here, 0 would be in the middle. You would be pretty much removing that point. So if you took that point 0 out, it would split this number line into two pieces. One from the left side of 0 to infinity, and then the right side of 0 to infinity. Parentheses is how you indicate that 0 is not being used. You would also have to use this union symbol, meaning you connect these two parts. So one restriction is if you have a fraction, namely with x in the bottom. If you have a fraction and x is not in the bottom, then it doesn't really matter. All right, second scenario is if you have an even root, even radical. So for example, if I have f of x equals, it could be square root of 2 plus x. It could be a fourth root of 2 plus x. It could be any even number in that radical. So that means odd numbers, this does not affect, only even. If you have this scenario here, this is what I'm going to focus on. Under a square root, the restriction is whatever is under the square root. So in this case, 2 plus x. Whatever is under the square root has to be positive. So the way we say positive, or non-negative really, is greater than or equal to 0, because 0 is a neutral number. So you can have 0, but you can't have a negative. So whatever is under the square root has to be non-negative. You solve for x, so we would have to subtract 2 from both sides, and that would give us a domain of x being greater than or equal to negative 2. So whatever you have an even root, you take whatever's under the root, and your domain has to be greater than or equal to 0, and then you solve for x. So that's the second scenario. And then scenario number 3 is if you have a log. So for example, f of x equals, we'll just say log base b of x plus 6, for example. Whatever you're evaluating the log of in those parentheses, that has to be greater than 0. It's kin to a radical. So whatever's you're evaluating the log of, so in this case, domain x plus 6 strictly has to be greater than 0. It has to be positive. You would solve for x by subtracting 6, and that would give you a domain of x is greater than negative 6. So as long as you pick a value greater than negative 6, that would work. All right, so these are the 3 problem areas that we would look for when we find a domain. If none of these 3 issues are present, our domain is automatically all real numbers. So if I look at this function here, I don't notice any fraction with x on the bottom. I don't notice any even radical. I don't see square root or fourth root or something of that nature. And I also don't notice a log. So none of these are present, which means domain is all real numbers. Okay, and the one that says all real numbers is D.